This is CPM Calculus, Chapter 4, number 142. So here we're asked to find the value of a such that the function f of x is differentiable at x is equal to 1. So f of x here is a piecewise defined function, one piece when x is less than 1, and another piece when x is greater than or equal to 1. So remember, differentiable would mean that f of x has to be continuous at x is equal to 1, right? And also, f prime of x is exists, right? At x is equal to 1. All right? So first of all, continuous at x is equal to 1 means that when x is 1, both pieces are equal, right? So at x is equal to 1, x plus 2 squared minus 3 equals a times sine of x minus 1 plus 6, right? This is just the continuous part. So, continuous. F prime of x exists, so let's write that. F prime of x exists is talking about, well, at x is equal to 1, the derivative of this and the derivative of this are equal. So let's go ahead and say dx of x plus 2 squared minus 3, right? The derivative of this has to equal the derivative of a times sine x minus 1 plus 6. Okay, so let's go ahead and do both of these. Well, let's start with f prime of x. Okay, we could do that one later. Pretty simple. The derivative of this, I'm going to use a different color, is just the power will bring down to 2, so it's 2 times x plus 2 minus 0, right? The derivative of this, we know, well, the derivative of sine is cosine, so it's going to be a times cosine of x minus 1 plus 0, right? So we know, so far we know, and it has to be at x is equal to 1, so 2 times 1 plus 2 has to equal a times cosine of 1 minus 1, right? Cosine of 1 minus 1 is cosine of 0. Cosine of 0 we know is 1. So a has to equal 2 times 3. A has to equal 6, right? Well, let's make sure that that works out for where x is, to show that x is continuous. So at x is equal to 1, this is just 1 plus 2 squared minus 3. 1 plus 2 is 3. 3 squared is 9. 9 minus 3 is 6. So I'm just simplifying the left side. On the right, we have a times sine of 1 minus 1, right, plus 6. That's just equal to a times sine of 0 plus 6. Sine of 0 we know is 0. So this is just saying 6 is equal to 6. So this is always going to be true. So to find out what a is, we're only looking at the derivative. So a has to equal 6. Okay? So for f of x to be differentiable at x is equal to 1, a has to equal 6. That ends CPM Calculus Chapter 4, number 142.